This is a specific heat capacity required practical revision video. There are two ways of doing this practical. The first way involves an ammeter in series and a voltmeter in parallel. The power supply is attached to the immersion heater. Immersion just means inside. It could be inside a metal block, it could be inside water, it could be inside oil, it could be inside any liquid. And I've put this into the next video to represent that it could be in a liquid. So first of all, we need to get the mass of the block using a balance. So for example, that block could be 2 kilograms. We need to know the mass. We need to know how much energy is going in, which we'll come to in a minute. And we need to know the change in temperature. So we use the thermometer to get the start and every minute. So we need to use a timer too. And once we've done that, we can use our ammeter and our voltmeter to get the power. So power equals current times potential difference. The current's from the ammeter, the potential difference is from the voltmeter. Now we've got the power, we can get the energy from power times time. The power we've just worked out, the time we get from the timer. And now we've got the energy. Now we've got the energy, we can use energy equals mass times specific heat capacity times temperature change. The temperature change coming from the thermometer. Temperature change, we get the temperature at the start, get the temperature every minute, so we know the starting temperature, we can work out the temperature change over the whole experiment. The mass we get from the balance, the energy we've just got from that equation. You substitute the numbers into the equation and you calculate the specific heat capacity after rearranging. There is an easier method though of getting the specific heat capacity, and that is to use a joule meter instead of an ammeter and a voltmeter in parallel. Joule meter is a meter that measures the joules, so it measures the energy. You could use this immersion heater in a liquid, oil, water, milk, or you could put it in a solid like we did in the first one, doesn't matter. You still need to know the mass of the substance, whether it's a metal or liquid. So let's say we've got 2 kilos. You still need to know the temperature, so you use a thermometer, and you still need to measure the time, record the time every minute. But in this case, we don't need to use the power equation, we don't need to use the energy equation. We can go straight to the E equals mass times specific heat capacity times temperature change. Temperature change we get in the thermometer again, the mass we're getting from the balance again, and this time our joule meter gives us our energy. We put the numbers into the equation, we simplify, we rearrange to get our specific heat capacity. A more complicated way of getting the specific heat capacity could be got by either method. We draw a graph, so we've got the energy in joules on the x-axis and we've got temperature on the y-axis. And it won't start at 0 because of room temperature, and it won't heat up straight away because the heat element itself will need to warm up. Once the heat element's warmed up, the temperature will increase. So we draw a line of best fit. Now to get the specific heat capacity from this, we need to calculate a gradient. So nice big triangle, do the change in y, the change in x. So our gradient is the change in y divided by the change in x. So let's say our gradient works out to be 10, for example. Our change in y divided by change in x equals 10. To get our specific heat capacity, we need to do 1 divided by the gradient, and our gradient just then was 10, so 1 divided by 10 would give us 0.1 joules per kilogram per degree C. And that's a more complicated method of doing it, but it's still valid, and they may give you the data and ask you to work it out.